Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No, we've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems and want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too. And especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Everybody, welcome to Wednesday Night Math Night. It is one of my favorite times of the, I was going to say of the year, but of the week. You can tell it's been a long week. I am in a new spot. If you're like normally with me, I'm in a spot with a rocking chair, so I'm going to try not to rock the entire time. It might make you dizzy, but I'm really like a little kid when it comes to this kind of stuff. Or clicky pens, I click all the time. So you can't put a clicky pen in front of me. Anyways, wow. We just got off on a random tangent. Well, welcome to Wednesday Night Math Nights with me. Hey, Chris. Hey, Hope. Hey, Denise. Hey, Bernadette. It is good to see some familiar faces here. If you are new with us, I am Amy Sink, and I am one of the proud math specialists here at the Learning Liaisons. My partner, Priya, is also amazing. Sometimes you see her here, too, on Wednesday math sessions. She also does tutoring, just like I do. We are really just here to help you. That is why we are here together. It is to help you be successful on those math certification exams because they are no joke. It is hard. I get it. So that's why we're here. Before I get started, I always like to do a little get to know you. So comment in the comment box where you're from, what test are you prepping for, and do you love a good thunderstorm? That question just popped into my head because it is thundering bad outside. My dog, we have a Great Dane, and he is godforsaken terrified of thunderstorms. You would think that he would be the bravest dog on the planet, and he is not. I love a good thunderstorm. Not when I'm out and about with my child, but I love being home with a good thunderstorm. So where are you from? What test are you prepping for? And do you like thunderstorms or not? While we are working today, I want you to comment in the comment box any questions you might have. Let me know what questions you have because that's going to help me help you kind of understand these problems because that's why we're here. It's not for me to just sit in front of a screen and solve a bunch of problems. It's for me to help you. So comment in the comment box whatever questions you might have. And if there's anything specific that you want to see me go over in the upcoming weeks, you can let me know that too. You'll notice some of the problems have a little asterisks, and that just means that it was a specific request. So without further ado, let's get started. Hey, Marissa, good to see you. All right. Denise, you say you're getting ready for the general subject test. Are you getting ready for the GKT in the state of Florida? Or are you getting ready for like a subject test for another grade level? Just kind of wondering. That's all. All right. Hi, Marissa. You don't like thunderstorms. That's okay. That's right. Math 6 through 12. I did know that. We've talked about that before. All righty. Somebody specifically asked last week, actually not somebody, a few somebodies specifically asked last week for standard deviation. Now, what I'm going to say about standard deviation is this. Standard deviation on the GKT looks something similar to this. Any of the upper level math, could you have standard deviation on your exam? Yes. Will it look like this? Maybe. Could they ask you to find the standard deviation? Wow, I am struggling right now. They could ask you to find the standard deviation, but here's the thing. I know somebody specifically asked for 6 through 12 standard deviation. Unfortunately, we are only here for an hour each week. And to do the standard deviation for a set of data by hand is an extremely long process that only a very specific group of people need to know how to do. And quite frankly, I would not waste my time studying how to do the standard deviation. If I were you and I got a standard, how do you find the standard deviation question on my exam and I was taking 6 through 12, honestly, I would skip it and know that I have the knowledge to pass that exam with everything else on that exam. Finding standard deviation by hand with a set of data is extremely long, extremely tedious, and sucks out a lot of time. And it's just not a good use of your time on that exam. If you know how to do it, great. If you want to study how to do it, great. But if you don't know how to do it, I wouldn't worry about it, to be honest. It is not going to be a huge chunk of your exam. I think on the Florida, it's like probability and statistics is like 8% of the exam, which is less than 8 problems. And there's other stuff included in that. Does that make sense? So you need to understand how standard deviation works, but I would not waste my time learning how to find standard deviation. All right, I'm off my soapbox. Let's talk about this problem. The distribution of daily high temperatures in July in Las Vegas is approximately normal, with mean of 105 degrees Fahrenheit and a standard deviation of 5 degrees Fahrenheit. Based on the distribution, which of the following is the best estimate of the percent of days in July that have a high temperature between 95 degrees Fahrenheit and 100 degrees Fahrenheit? All right. When we see distribution, we know that we are looking for a spread of data, which usually means we're looking at standard deviation. So that said, we need to know that standard deviation falls on a normal bell curve. So this line is not straight. I want to get it as straight as possible. So if I were to draw a bell curve, it would look something like this. And that wasn't really great. Oh, okay. Third time's the charm. Yes, third time's the charm. That'll be the best one that we have. So what this bell curve represents is the data that we're describing. And what's the data that we're describing? Temperatures in July. So on July 1st, we're just going to do July and we're going to do temp. So on July 1st, it was 100 degrees. On July 2nd, it was 105 degrees. On July 3rd, it was 102 degrees. On July 4th, it was 108 degrees. On July 5th, and so on and so on and so on through the end of the month. We don't know the data. They did not give us the data. I'm literally making these data points up, but I'm trying to show you what a bell curve means because we all need to understand just how data operates. So the mean is the what? The mean is the average, and I like to remember that because the mean is very mean. It makes you do a lot of work. And the average, you have to add all the data points up and divide by the number of data points. If it said the mode is the data point that appears the most. The median is the middle point, and the range is the difference between your highest and lowest data point. Again, that has nothing to do with what we're doing right now, but I like to just rabbit trail for some of my people who don't need to know about this. So the mean is 105. That means that this number right here in the smack middle of my bell curve is 105. With a standard deviation of 5 degrees. That means that I'm going to draw dotted lines and I'm going to add 5, add 5, add 5 from my mean. And I'm going to subtract 5, subtract 5, subtract 5 from my mean. So this is going to be 110, 115, 120. This is going to be 100, 95, and 90. So then if standard deviation is something you need to understand, you need to know in your brain what percentages fall in each of these categories. So, and you'll see some small variations in these numbers. I wouldn't hang my hat on that, okay? And I'll show you why. So the graph I'm remembering is 34.1% goes here. And again, you might see something about like 32 or 33. You might see a 13.6 here, or you might see a 12. That's okay. I don't want you to hang your hat on that. And then 13.6 and 2.1%. What does all of that mean? That means that 34.1% of my data points of the temperatures in July are going to be between 100 and 105. 34.1% of my data points are going to be between 105 and 110. 13.6% of my data points are going to be between 110 and 115. 13.6 are going to be between 95 and 100. So if I think about the fact that there are 30 days has September, April, June, and November, 31 days in July, and I multiply that by 13.6%, that is about 4 data points. So 4 of my days in July are going to be between 110 and 115, and 4 of my days in July are going to be between 95 and 100. That's what all of this means. Now, if you memorized a graph that said that this was like 33 and this was 15. Let's pretend. It wouldn't be a big deal because let's look at the question. Based on the distribution, which of the following is the best estimate, the closest, of the percent of days in July that have a high temperature between 95 and 100? Well, 95 and 100 is going to be right here, this section right here. And my graph says 13.6. But their answer choices say 13.5. You might have remembered 12.9. Which of those is the closest to that? That's all I'm asking. Now, let's do another question about that. Let's copy and paste this. I want to see if you guys can do it. Ready? So I'm going to erase all of this, and I want to ask. Let's do another question for this. Based on the distribution, which of the following is the best estimate for the percentage of days in July that have a high temperature between 105 and 115? What are you going to do in that situation? What are you going to do in that situation? You're going to add the percentages together. So you're going to take, if we're going from 105 all the way to 115, I'm going to go from here all the way to there. So I'm going to do 34.1 plus 13.6, and I'm going to get approximately 47.7. Again, they might have 47.8, 0.9, 48%. If they said 50%, I would know that that would be wrong. Why? Because 50% would be everything on this side of the table. And so because they didn't include that 120, I'm not going to say it's 50%. That was a lot of information about standard deviation. Does anybody have any questions about that? I'm going to go ahead and move on to the next problem. If you have any questions, please don't hesitate to ask. I'm always willing to come back to this problem if I need to. All right, problem number 2. A line Q, is graphed on the XY coordinate plane. Line Q is represented by the equation 3x minus 4y equals 16. A line perpendicular to line Q is drawn and passes through the point -3, 5 and is identified as line Z. Which of the following points sits on line Z as well? This is an interesting one, and someone specifically asked for me to do a linear equation tonight. You're welcome, Bernadette. I'm glad that makes sense. I'm not going to lie, Bernadette, I did not get to problem number 2 because I have to do research on how to solve that problem. Because like I said, I am not that great at probability and statistics. Okay, I can, but I have to study it. So I am still looking into that problem. So someone specifically asked for a linear equation. So here we go. A line Q is graphed on the XY coordinate plane. So here's my XY coordinate plane. And line Q is graphed. Line Q is represented by this equation. And then it says a line perpendicular to line Q. What do we know about perpendicular lines? Perpendicular lines have negative reciprocal slopes, which means if line Q has a slope of AB, line Z is going to have a slope of -B over A. So, yes, the negative reciprocal, Denise. I love that. So, what is the slope of line Q? So many people are tempted to say 3 because we think y equals mx plus b is our linear equation slope-intercept form. And we know that m is slope. So people automatically assume that anything next to the x is the slope. But this is not slope-intercept form. This is standard form. So I have to take my standard form equation and put it into slope-intercept form. So 3x minus 4y equals 16. Subtract 3x from both sides. Negative 4y equals negative 3x plus 16. Why did I write it that way and not 16 minus 3x? Because mx is first in my slope-intercept form. Now I'm going to divide both sides by negative 4, which means I need to divide everything. And I get positive 3/4 x minus 4. So the slope of line Q is indeed 3/4. Rise over run. So if I were to graph that, which I don't have to, I'm going to graph it just for visuals, but I really don't have to graph it. I'm going to plot my y-intercept. And again, I'm going way beyond how I would actually solve this because I like to give little snippets. So this part I would not do in this problem. I'm going to graph my y-intercept because in slope-intercept form, this is my y-intercept, which is where the graph crosses the y-axis, and m is my slope. So I'm going to plot a point at negative 4. And then I'm going to rise 3, and I'm going to run 4. And then I'm going to rise 3, and I'm going to run 4. And there's line Q. Now, it says a line perpendicular to line Q. Perpendicular lines intersect at a 90-degree angle. And it passes through point negative 3, 5. 1, 2, 3, 1, 2, 3, 4, 5. And I'm going to draw a line that's a 90-degree angle from that. And I'm quickly realizing that none of my answer choices are going to make sense. But let's go ahead and solve it and see why. So now I know I need a line that has a slope of what? The slope of line Z is going to be negative 4/3. Why? Because it's the negative reciprocal of line Q. So I'm going to flip 3/4 and I'm going to negate it. Now, watch what happens. I have y equals mx plus b. What else do I know about line Z? What else do I know about line Z? It passes through negative 3, 5. So if I plug in negative 3, 5 into that equation, I plugged in the 3's are going to cancel out, and I'm going to get 5 equals 4 plus b. Now, if I subtract 4 from both sides, I get b equals 1. Now, I know the line perpendicular to this line, because of this slope that passes through this point, because I plugged that x and that y into my xy, gives me this equation, -4/3x plus 1, because I solved for b. Now, I can take any of these x points and plug it into my equation that I just found to see which point makes most sense. Now, I'm already realizing when I solved this problem what my error was. So you know what? We're going to go Praxis style. We're going to go Praxis style because you know what the Praxis does? The Praxis will say, what is a point? What is a point that sits on the line as well? And you can give any point. So now if we were to get, well, we made it 26 minutes. Those of you who hang out with me every Wednesday, you know the drill. My iPad likes to disconnect and we really have no idea why. So if it said, what is a point that passes through line Z, you could pick any X value, plop it in, and it'll spit out an answer. So I'm going to pick X equals 2. So y equals -4/3. I'm actually going to pick X is 6 because I want a point that's going to cross off my denominator. Oh, I just realized that I'm solving over here and I haven't presented my screen. That's not helpful. There we go. So this is going to cancel with this. I get y equals -8 plus 1. So y equals -7. So we have 6, -7. Denise picked 0. That was an excellent strategy. She plugged 0 in and got 0, 1. It really doesn't matter which one you pick. I just wanted you to see a multi-step linear equation problem. And so that's what we just did. All right. Any questions about that one? I am going to go ahead and move on to problem number 3. But if you have specific questions about that problem, please let me know. A box shaped like a rectangular prism has a length of 6 centimeters, a width of 5 centimeters, and a height of 8 centimeters. A teacher wants to fill the box with cubes that have a height of 1/2 centimeter. How many cubes can fit in the box? This is one that people reverse all the time. So let's draw the box because I want you to see when I draw this box what we're talking about. First of all, when we're talking about how many cubes can fit in any box, pyramid-shaped box, cone-shaped box, rectangular prism-shaped box, what measurement are we talking about? Volume. You're absolutely right. We are talking about finding the volume of the box. So let's draw the box. Here is my box. Here is my box. My box, my box. Okay. And it has a length of 6, a width of 5, and a height of 8. In a rectangular prism, not pyramid, in a rectangular prism, does it matter if I put the 6, 5, 8 there and you put the 6, the 8, and the 5 here? It really doesn't, because volume is length times width times height of a rectangular prism, because we know that volume of any prism equals the area of the base times the height, and area of the base in a rectangular prism is a rectangle. So it's length times width times height, and multiplication is commutative. So it really doesn't matter. So just wanted to let you know that. So that said, the volume of this box is 6 times 5 times 8, which is 30 times 8, which is 240 centimeters. If they said, how many 1 centimeter cubes could fit, we would be done. But that's not what they said. They said, how many cubes with a height of a 0.5 centimeter fit? Well, you would think that because it's 1/2, I would just multiply it by 2 and be done. But when we're talking about volume, that is not how it works. I want you to visualize it. It's a cube, so it's a 1/2 all the way around. So if I draw a little 1/2-inch cube in here, I'm going to zoom in. It's 0.5 and 0.5. And it's going to go 0.5 in the other way. How many 1/2-inch cubes can I fit going along this, or 0.5 centimeter cubes can I fit going along this 5 centimeter section? Well, I'd have to have 2 of them to make a whole centimeter, right? And if 2 makes a whole centimeter, it's going to take 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are really not to scale, but that's okay. It's going to take 10 of them to stretch across that entire thing because they're each a 1/2 centimeter. So to make a whole centimeter, it's 1. So instead of 5 centimeters, I'm going to say that this is 10 cubes. And instead of 6 centimeters, I'm going to say how many cubes is that? 12 cubes. And instead of 8 centimeters, how many cubes is that? 16 cubes. Now if I do my volume, 12 times 10 times 16, use my handy dandy calculator, we get 1,920. It's a lot of cubes, isn't it? Any questions about that problem? All right, let's move on to problem number 4. The equation below represents the cost C a customer must pay a plumber after H hours of work. Marissa, go for it. You do not even have to wait for me to acknowledge you. Just type in any question that you have and I will happily answer it. That's what I'm here for. And I may have to go back depending on when your question comes through. The equation below represents the cost C a customer must pay a plumber after H hours of work. Which of the following most appropriately describes what 75 represents in the equation? So when I see this, I immediately think y equals mx plus b, knowing that b and m are usually numbers and y and x are my variables. This kind of looks like that, right? So the equation represents the cost a customer must pay after H hours of work equals 30 times hours plus 75. Which of the following tells us what 75 represents? So if this represents, and I'm going to actually cut and paste it here and make it bigger. So this represents the cost that someone is paying. So 75, excuse me, 75 has to represent a money value because this whole thing equals the amount of money, which means this has to be an amount of some sort. So when I look at A, B, C, and D, the first thing I'm going to look for is something like hours, because that's not going to make sense. So the initial fee charged by the plumber before any work is done. The total amount of money the customer must pay after the job is complete. The amount of money the customer must pay per hour. the amount of money the customer owes the plumber. So all of these are monies, or they are all in the form of fees. So I can't eliminate any answer. But when I think about this, if the plumber comes and does 1 hour of work, I'm going to put 1 hour right here. 30 times 1 cost equals 30 times 1 plus 75. 30 plus 75 equals 105. So if the plumber does 1 hour of work, I'm going to be charged $105. I'm telling you, when I look at this problem, and when some of you look at this problem, you know the answer right away because you really, really understand. But some of you, this is a really struggle problem. You're on the struggle bus with this problem, and that's okay. That's why I test numbers, because it helps me figure out what I'm dealing with. So now let's plug in 2. If the plumber works for 2 hours, I'm going to pay $60 plus that same $75. So what is that $75? Is that how much we're paying per hour? No. Per hour means I'm multiplying it times a number. That's what per means. Per hour, per mile, per minute, per whatever means I'm going to multiply something by that number. So the amount per hour is going to be 30, not 75. The total amount of money after the job is complete, that's what C is. That is not what the 75 is. The 75 is the initial fee, even if the plumber does nothing. 0 hours. If I plug in 0, 0 plus 75 still equals 75. So even if the plumber does no work, I'm going to be charged that $75 fee. And the amount of money the customer owes the plumber, that's a very vague response and is not a mathematically accurate response. Because how much the customer owes the plumber, well, if how much they have to pay the plumber at the end of the job would be the cost. But how much they owe the plumber, we don't know if the plumber makes you put down like a $50 deposit and then you pay them the rest when he comes. That would be more what they owe the plumber. In this situation, owing the plumber and the total amount of money the customer must pay after the job is complete is almost synonymous with each other. So we're not really looking at that. All right, let's go ahead and look at problem 5. Marissa, for the last question, could you divide the height and then multiply to solve? So divide the height, divide 8 by what? I'm not really understanding your question. I didn't divide anything in this problem because do you mean the height of the cube or the height of the rectangular prism? I guess I'm not clear on your question. I'm happy to answer your question. Just clarify your question for me a little bit and I'll come back to it and answer it. Absolutely. All right. Problem number 5. This is we're really sticking into linear equations tonight. I don't know why. It just kind of was something I wanted to do. Jocelyn and Matt purchased trees from the same nursery. Jocelyn spent $484 on 4 willow trees and 2 maple trees. Matt purchased 3 willow trees and 5 maple trees and spent $615. What is the cost of 1 maple tree? So if you have been with me for any amount of time, you know that if we're solving a problem that has more than 1 missing number, we're probably dealing with a system of equations. If we are dealing with a problem that has more than 1 variable or more than 1 missing number, we are probably looking at a system of equations. So a system of equations is when we have two lines working together and we're trying to find their intersection point. So what is the cost of one maple tree? Let's go ahead and look at this. So I know that 4 willow trees. I'm literally taking this sentence, reading it out loud, and spitting it onto the paper. And add, because if I was at Home Depot and I was buying these, I'm buying 4 willow trees. So each willow tree is $80. 80 plus 80 plus 80 plus 80 plus 2 maple trees equals $484. But then I cannot do anything with that because I have 2 variables. So now I need to see what Matt purchased. Matt purchased 3 willow trees and 5 maple trees and spent $615. Now, last week when I solved a system of equations, there was a question on why I multiplied one over the other. It does not matter which one you multiply by what. What you're trying to accomplish in this situation is getting a variable to eliminate. I'm using the elimination method. Could you use substitution? You could. It would just be a really lot extra work for this problem, the way it's set up. I'm using elimination. So my goal is to eliminate one of my variables. How am I going to do that? Can't do it the way it is right now. Because if I add these together, I'm going to get 7 W's plus 7 M's equals something. I'm still going to end up with 2 variables, and that's not helpful. So I'm going to multiply each equation by something to eliminate. I'm going to eliminate the M's. So I'm going to multiply the top by 5, and I'm going to multiply the bottom by 2. Because if I multiply the top by 5, that becomes a 10. And if I multiply the bottom by 2, that becomes a 10. And then I can subtract them, okay? But I'm going to multiply everything. I'm going to distribute. So I'm going to get 20 W's plus 10 M's equals, I'm going to use my calculator for this one. 2,420. And then I'm going to distribute this. 6 W's plus 10 M's equals 1,230. Now I'm going to subtract these equations. But when I subtract, everything is subtracting, not just the 6. 20 minus 6 is 14 W's. 10 minus 10 is 0. I eliminated my M's. Equals 1,190. Divide both sides by 14. And W equals 85. Now, am I done? No, because they asked, what is the cost of one maple tree? I'm looking for the cost of a maple tree. What did I just find? The cost of a willow tree. So now I'm going to take that 85 and plug it back in. So 4 times 85 plus 2m equals 484. 4 times 85 equals 340 plus 2m equals 484. Subtract 340 from both sides. 2m equals 144. And when I divide both sides by 2, I get m equals 72, which is the cost of one maple tree. Now, here's what I want you to know. Someone else in this room might, there goes my iPad, like usual. Someone else in this room might have eliminated the W and solved for M. If they did that, they would have gotten M equals 72 and they would not have had to plug it back in. It doesn't matter which way you do it. What I want you to recognize is that there's a lot of different ways to solve using elimination. And so as long as you understand the process, you get to pick how that looks. Does that make sense? Any questions? Oh, well, it was at 6. I live in Florida, so 6 o'clock Eastern time is what time I started. I'm not sure where you live. So if you live in Texas or California or Paris, it would be a different time for you. But I am in Florida, and so it was 6 o'clock Eastern time. Where do you live? I'm so sorry that you missed it. We will be here next Wednesday at 6 o'clock Eastern time, just like every other week. But I am sorry that you came in at a different time. So, but yes, you can rewatch it later, and then you can always come in next week, and I will be here live at 6 o'clock Eastern time. So, all that said, you can eliminate a different variable if you did it a different way. Can you divide height by 2 and then multiply the new number and the remaining numbers to get the answers? Marissa, I am so sorry. I'm really still, I thought we were going to lose it again. I'm still not understanding dividing the height by 2. If I divided 8 by 2, I would get 4. And if I divided 5 by 2, I would get 2.5. And if I divided 6 by 2, I would get 3. And that would definitely not get me the answer, because if I divided everything, but if I divided this by 2, yes, you could do that. I'm just not sure what your question is. If you want to email me too, like how you solved the problem, and then I can circle back. Divide the height of what is my question? The height of the prism or the height of the cube? Because those are two different things. You live in Texas. I figured. And yes, I can do quadratic functions and vertex questions next week. Absolutely. And I always ask that. So I will put the next week list right here. I always like to do a next week list. So we will absolutely do vertex and quadratic functions. Chris, that's an excellent idea. I love that. Or not Chris, Shayton. For some reason I saw Chris. Shayton, that's an excellent question. And I hope I said your name right. Okay. We have time for like one more problem. I kind of got distracted with that, but the height of 8 is the rectangular prism. Yes. So if I divide the height by 2, if I divide 8 by 2, and then multiply 2 by everything else, that is not going to give me the right answer. But again, if you want to email me at more_Amy@hotmail, or send me a message on Facebook, Amy Sink, of a picture of what you're talking about, I'll be able to better understand what you're talking about. And that way I can better answer your question. That's the only unfortunate thing about us being live here, is that I can't like literally speak to you. So we use the comments the best we can, but I can't literally talk to you. Oh, yay, I'm glad I said it right. I hate when I say people's names wrong. That's like your identity. All right, we have time for maybe 1 or 2 more problems. Then I'm going to turn it over to you guys and ask if you have anything you want to see me solve next week. And then we're going to turn it back over to Dr. A, and then we will be done. So Which of the following expressions matches the sentence shown below? Which of the following expressions matches the sentence shown below? Whoo! I get on a whole kind of train about this one. The difference of 3 times a number and 7. Actually, I want to do this one first. It's the same problem. It's the same problem, okay? It's just different words. So, 5 more than the product of 4 and a number. So, if I was to literally translate that, there goes my iPad again. There are some weeks where it literally doesn't disconnect. There's some weeks it disconnects once, and then there's some weeks where it literally disconnects like 17 times. And I feel like tonight I'm over exaggerating because I'm dramatic sometimes, but I feel like this week it's disconnecting so many times. Okay, so 5 more than the product of a number, 4 and a number. Okay. 5 more than, 5 plus the product of, I'm going to be multiplying something times something else, 4 and a number, 5 plus 4x. The only one that is 5 plus 4x is this one. But if I look at commutative property, this is also 5 plus 4x. So which one is it? And this is where it gets complicated, okay? So, yes, 5 plus 4x and 4x plus 5 are technically going to give me the same answer because addition is commutative, but subtraction is not. The difference of 3 times a number, 3 times a number, that whole chunk is together, and 7. So I am subtracting these 2 things. But what order am I doing it? Am I doing 3x minus 7, or am I doing 7 minus 3x? Let's think of this. The difference of 8 and 2. And the difference of 2 and 8. The difference of 8 and 2 is 8 minus 2. The difference of 2 and 8 is 2 minus 8. So the answer to this problem is 3x minus 7. However, wording of these is critical. If I look at 5 more than, I'm looking at something plus 5. Because if I look at 5 less than, we're looking at something totally different. 5 less than what? Something minus 5. The product of 4 and a number, 4x. Why? Because 5 less than 7 is not 5 minus 7. 5 less than 7 is 2, which means you did 7 minus 5. So if we have something more than or something less than, it means it's something minus or plus that number. If we have the difference of, then we just do it in that same order. The English language translating to math is extremely tricky. And I want you to know that it matters when you're translating stuff like this. Okay? That was a lot of math today. We only got through about 6 or 7 problems, but that is okay. Here's what I want you to do. I want you to let me know what you want to see me going over next week. Bernadette, I'm absolutely going to go over that probability problem next week. But everybody else, what do you want to see from me next week? Vertex, quadratic functions. And I can't promise we're going to be here next week due to the July 4th holiday. We will let you know on social media. So if we are not here next week, you will definitely see me the following week. But just know if we're not here next week, that's why. Trig, specifically what kind of trig? Like sine, cosine, tangent? Like what are you kind of looking for? I am going to turn it back over to Dr. A, but I will keep this open while he's talking, and then I will see you either next week or the week after, depending on if we have math night due to the holiday. If not, have an amazing July 4th, and I will see you all soon.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.